concept called binding, or we can call as a linking, right? Can I say this linking concept or binding concept related to calling function and called function? Again, this linking concept or binding concept related to calling function and called function. Suppose when one function is calling the other function, when one function is calling the other function, when this function will get the address of this function, when the address is resolved, that is a discussion happen. I told you address is resolved in a 3 different steps. One, maybe address is resolved, address can be resolved in a 3 different things. One is 3 different times. One is compile time, yes, and another one is a load time, yes, and another one is a run time. Now can you tell me, when I compile the program like this, the binding between the main and printf is what? Is compile time or load time or run time? Can you tell me, when you compile the program like this, the binding between the main and printf is what? Answer is load time. Load time. Can you tell me, when I write cc hyphen static p1.c, in this case, the binding between the main and printf is hyphen static. The binding between the main and printf is, can I say, it is a compile time. So what is the use of a runtime? Yesterday we are trying to understand. Yesterday I told you, suppose we designed one application, one a.out file. If this a.out requires 100 libraries, logically think in the RAM, if your a.out is loaded, if all these 100 libraries are loaded, unnecessary the RAM space gets wasted. So to utilize the RAM space effectively, yesterday we discussed one method that is called runtime linking. Will you agree? To utilize this RAM space effectively, we discussed one method that is called runtime linking. Now can you tell me, what are the functions involved in a dynamic runtime linking? Can you tell me, what are the functions involved in the dynamic runtime linking? Can I say DL open, DL sim, DL error, and DL close? Again, DL open, DL sim, DL error, and DL close. DL open is for opening the library. DL sim is for getting the function address, symbol address in the library. DL error is for displaying the proper error message. DL close is for unloading the library. Can you tell me, upon failure, what is a DL open returns? Upon failure, what is a DL open returns? 0. Upon failure, what is a DL sim returns? Upon failure, what is a DL sim returns? Can I say that is also 0? Observe this program. In this program, we declared one function pointer and we declared one void pointer. Observe this program. We declared one function pointer, we declared one void pointer. And we are taking the decision at runtime which function we need to call. If option is 1, we are loading the library, we are getting the function address, we are calling the function through function pointer, we are closing the library. Again, if option is 1, will you agree, we are loading the library, we are getting the function address in that library, we are calling the function through function pointer, we are closing it. Now can I say, in this concept, you cannot call the sum function directly. In this, you cannot call the sum function directly. Now can you tell me, when you compile this program, are you supplying your own created library? When you are compiling this program, are you supplying your own created library? Your own created library name at the time of compilation, be8, v5. When you're compiling this program, are you supplying your own created library name, libmno.so? Tell me here, Yamai supplied libmno.so? No, right? be8, v5. We are not supplying our own created library here. Now, can you tell me when our library is loaded? Can you tell me when our library is loaded? Only when I give the option as 1 or option as 2. Will you agree? Only when, if I give the option as 1, my program is running. My program is already running. Then if I give the option as 1, then only my library is loaded. libmno.so is loaded, and we are getting the function address at runtime. We are calling the function. We are closing the library. Will you agree? We are closing the library. Now you may get a doubt, sir, if I call the sum function, what happens? You may get a doubt, sir, if I call the sum function here, what happens? If I call k is equals to sum I comma j. If I want to call the sum function directly, I must and should supply the library name here. Otherwise, linker will generate undefined reference to. If I want to call the sum function directly, will you agree? Here I must and should supply the library name. Here I must and should supply the name of the library. Otherwise, linker will generate an error. If I supply the library name here, can I say when my a.out is loading, that library also loaded? I don't want that, right? All of you are getting the point. If I might have supplied my own library name here, will you agree when my a.out is loading, that library also loaded? But I don't want like that, right? First, my a.out will go to the RAM. When my a.out is running, depends upon the requirement. I need to plug the library. I need to put the library. I need into the RAM. I need to utilize the function. I need to close the library. So, in this runtime, dynamic runtime concept, without a function pointer, you can't write the program. If you want to achieve the dynamic runtime linking, will you agree? Without a function pointer knowledge, you can't call the function. I don't know you remembered or not. When we started with the dynamic memory, also the same thing. When we started with the dynamic memory, also the same thing. Malloc and calloc returns the void pointer. So we need to catch with a pointer. Then we need to process the data. Will you agree? When we are dealing with a dynamic memory, we can't process the data directly. Only through pointer we need to process. We can't process the data directly. Only through pointer we need to process. Similarly, in a dynamic runtime linking, we can't call the function directly. Only through function pointer we need to call it. Only through function pointer we need to get the address. Can you tell me here? Here, main function is getting the sum function address at what time? Can you tell me here? Main function is getting the sum function address at what time? Yes, it is a run time. It's not a load time. V5, be8, v5. It is not a load time. It is a run time. If option is 1, then only these lines will execute. Will agree? If option is 1, then only all these lines will execute. Otherwise, these lines will never execute. Otherwise, those lines will not execute. If option is 1, then only my library is loaded. Otherwise, my library is not at all loaded. libmno.so. When you use RTLD lazy flag, then what happens? My library is not directly loaded into the RAM, it is loaded into virtual memory. Those who don't know the virtual memory, don't worry. It is a part of the hard disk. First, it is loaded into virtual memory. From the virtual memory, it is loaded into the RAM. From the virtual memory, it is loaded into the RAM. If you use RTLD now, it is directly loaded into the RAM at the time of line number 12 execution. Now I'll wait for a few more minutes. If any doubts are there regarding the library, entire library is loaded. K5, entire library is loaded, not the only some function. There is no other option to load only one function in a dynamic library case. Entire library should be loaded. Now I'm going to wait for 2 more minutes. Any doubt regarding the library concept? Please let me know. How many of you understood the difference between the static library and dynamic library? And how many of you understood where we need to go for a static library, where we need to go for a dynamic library? Now, can you tell me in which case I can fix the bugs in my application very easily? In which case I can do the enhancements very easily without disturbing the customer data? Can I say in a dynamic? In which case I can use my RAM more effectively, even though my application need more libraries, all the libraries no need to be loaded. In which case can I say dynamic runtime linking case? Dynamic runtime linking case. Can we supply the library path present in other folder? Yes. If it is present in another folder, you need to supply the path here in line number 12. Yes, you can. Any doubt in this? Any doubt in the concept of a library? In which case, whatever the functions you are calling, those function definitions are added into your executable file. In which library? Static. One of the student is asking one question. Let me read it. Sir, if given luxury of RAM storage, then the dynamic linking is preferred. Yes. If you want to think about the RAM space, if your application need less memory, if you want your application should require less memory, then you need to go for dynamic runtime linking. One of your friend is asking M5, sir, can we first open the library? You are asking this line, can I write above this if? Is it? So then try to logically think, if option is 1, then only I need to open. So why you need to load the library unnecessarily if option is not 1? M5. Again, that becomes a wastage. Again, unnecessary RAM space wasted. BE9 M5. You can do it. This is our program. We can write it as we wish. But logically think that advantage we are going to lose if you open the library without scanning an option and all other things. BE9 M5, getting the point? Okay. So again, still I'm waiting for some more time. If you have any doubt regarding the libraries, you can ask it. So that we'll start with the next discussion. More about DLFCN. Header file, that is a header file. Can you tell me what is that header file contains? Header file contains these function declarations and these macros. BE9D3, that is a header file. That header file contains DL open, DL sim, DL error, DL close function prototypes, as well as it contains the macros, RTLD, lazy RTLD, now those things. I hope you got the point. Okay then. I'm thinking that I'm concluding that yes, you got why handler is a void pointer. See, good question here. Why handler is a void pointer? What is this DL open will return? This entire library starting address. Library is not a data type, right? If it is an integer, integer pointer. That is the reason some pointer, void pointer, generic pointer. S4, got the point. Yeah. Okay then. Next move to the concept of an operating system. Now, one thing I need to ask you, very simple, very basic question. All of you can answer it. Operating system is a hardware or software? Operating system is a hardware or software? B8, K2. Is it an hardware? Operating system, is it a hardware? Surprising answer. It is a software, right? Which is running on the top of an hardware. Can I say operating system is a software which is running on the top of the hardware? On the top of the hardware. Can you tell me, when you purchase a new laptop, when you purchase a new desktop without an operating system, can you use it? If you, when you purchase a new laptop, when you purchase a new desktop without a laptop or desktop, can you use it? Answer. Without an OS, can you use it? Answer is no. So you need to install the OS. So point number one is, operating system is a software component, not the hardware component. What is the role of an operating system? What is the definition of an operating system? Can I say, non-technical definition is, it is a mediator between the user and the hardware. Non-technical definition is, it is a mediator between the user and hardware. But technical definition is, OS is a resource manager. Technical definition is, OS is a resource manager. What is the meaning of resource here? What is the meaning of resource here? Resource is nothing but hardwares. Resource is nothing but an hardware. All the hardware components. Will you agree? Now I am taking the class through my laptop. Can you tell me what are the hardware components are there in my laptop? What are the hardware components are there? Can I say keyboard is there, inbuilt? Monitor is there, screen is there, inbuilt. Camera is there, inbuilt. I connected wireless mouse. Mic is there. I connected pen tab. Wi-Fi module is there. Will you agree? Wireless I connected. My house router is there. Through wireless I connected. So all these are, Bluetooth is there. Bluetooth is there. Wireless earphones are there. Hard disk is there internally. RAM is there internally. ROM is there internally. Will you agree? All these are the hardware components. All these are the hardware components. All these are the hardware components. Who is responsible for managing all these hardwares? Who is responsible for managing all these hardwares? Who is responsible for managing all these hardwares? Can I say, operating system is responsible for managing all these hardwares. Without operating system, we can't imagine the laptop, we can't imagine the desktop. Without operating system, we can't imagine the what you call laptop, or we can't imagine the desktop. So OS is a software component. OS is a mediator between this operating system is a mediator between this OS is the mediator between just a minute user and the hardware. Without operating system, it is very difficult to manage all these resources. Without operating system, will you agree? It is very difficult to manage all these. Without operating system, will you agree? It is very difficult to manage. Very difficult to manage all these components. Is it clear? Nowadays, will you agree? In an embedded system also, operating system involvement will be there. Previous days, embedded system means which can perform only one task. Will you agree? In a previous days, embedded system means which can perform one task. But nowadays, embedded system means which can perform multitasking. Which can perform multitasking. So nowadays, most of the embedded products are coming with embedded OS, the OS which is embedded into that specific hardware. The operating system which is what you call loaded into that specific hardware, that is embedded. If you take a very basic example of your smartphone, can I say that is inside that operating system will be there? Because of OS only, we can do multitasking. Because of operating system only, multitasking. Will you agree? Nowadays, one student, you need to be little bit patience. The student ID is BE8K5. Be little bit patience. Huh? Be little bit patience. I'll tell you all the things. Don't worry. BE8K5. Got the point? Okay. So nowadays, will you agree? Most of the embedded products are coming with inbuilt OS. Most of the embedded products are coming with inbuilt OS. Especially Linux OS. Will you agree? Linux is a free source code. Linux is a free source code. Linux can be loaded into different hardware architectures, whereas a Windows can be loaded into only two, Intel and ARM. Intel and ARM. But Linux can be loaded into different small microcontrollers also. So one major reason why Linux is becoming a popular, that is free source code. Second major reason is you can port it into different hardware architectures. Third major reason is there is no proprietorship. Proprietorship means Apple company, Mac OS is a proprietorship OS or free OS? Mac owner will be there, right? Windows owner will be there, right? Suppose you are developing one embedded product, you want to use a Windows OS into that. Will you agree? You must and should take a license for that. Getting the point? If you want to use Windows OS, free source code means operating system is a software. Operating system is a software, right? Operating system is a software, right? Software means code will be there, right? That code is a free. You can see from line number 1 to line number n. Anyone can download any for anything. Getting the point? Because of that, what happens is your product cost can be reduced. Because of that, your product cost can be reduced. BE8K8 is asking, sir, please write these points on the notepad. So BE8K8, so my sincere request to you is, if you might have Just a minute. If you might have attended this, otherwise I'll share this PDF to you. Just a minute, I'll share this PDF to you after the class. Why Linux we are discussing, right? Why Linux we are discussing, right? Hello, are you getting the points? All these points are there. Free source, open source code. Source code can be modified. No, I'll share this PDF. After that, you can note it down. It is there in our material also, I think. The source code can be modified and distributed. High security, large community support. High security, large community support. High performance. Now, embedded Linux. Embedded Linux are used in a different products like consumer electronics, set-top box, smart TV, smartphones. In-vehicle infotainment, luxury cars. Will you agree? In-vehicle infotainment, luxury cars. Will you agree? In that also is there. Network equipment such as routers, switches, wireless access points. Everywhere nowadays, whatever the embedded products are there, they are using the OS. When the OS is there, multitasking can be possible. When the OS is there, what happens is multitasking will be possible. One of the student is asking what is the difference between the OS and CPU. CPU is hardware. OS is a software. Getting the point? DE9V1. CPU means an hardware. OS is a software. Getting the point? CPU is an hardware. OS is a software. So there are so many advantages are there. One major advantage is free source code. Easy customization. Easy customization means according to your requirement, you can customize that OS, you can mold the OS, you can change the OS, you can configure the OS, you can use it. Used device specific purpose built applications. Purpose built means for what purpose you are building, that you can use this. Power consumption is also low, easy portable, large community support, performance optimization, low cost. These are some of the usages. These are some of the advantages of what is that? These are some of the advantage of Linux operating system. Will you agree? And if you work on the Linux, if you start developing on the Linux, other environments becomes very easy. Other things becomes very easy. I hope you got these 3 points. First point is, what is an operating system? OS is a software component. OS is a resource manager. OS is a mediator between the user and the hardware. Second one is, nowadays most of the embedded products are coming with inbuilt OS. The benefit of OS in embedded system, multitasking, and Red Hat is also Linux OS, correct? Red Hat is also Linux OS. If you have the capable, one more thing I need to tell you, Mac inside kernel is also Linux. Mac OS is there. Inside the kernel is also OS. What is a kernel? Don't worry right now. We are not yet discussed. Next point is, what are the components of operating system? Majorly, operating system contains the two components. Majorly, operating system contains the two components. One is applications, another one is services. Again, just a minute. Majorly, operating system contains two things. One is applications and another one is services. All the services combinedly called as kernel. Kernel is nothing but core of operating system. Again, Operating system contains the two components, two parts. One is an applications and another one is a services. All the services combinedly called as a kernel. Operating system is different, kernel is different. Kernel is a part of an operating system. All if you're getting the point. Kernel is nothing but a core team, core component of an operating system, core of an operating system. In this kernel, all the managers will be there. In this kernel, all the managers will be there, like process manager, which is responsible for managing the processes, like memory manager, which is responsible for managing the RAM, file manager, which is responsible for managing the hard disk, network manager, which is responsible for receiving the data from the network, thread manager, which is responsible for managing the thread, signal manager. All these things are present in the kernel space. All the managers are combinedly called as all the managers are combinedly called as can you tell me? Kernel. KERNEL, kernel. Kernel is nothing but a core of an operating system. Kernel is nothing but a core of an operating system. Major component of an operating system. So like in any company, the core team will be there, right? In any company or any place, the core team will be there. Kernel is also present in the Windows. Yes. Kernel is nothing but different managers. File manager responsible for managing the file. Network manager responsible for managing the network. Memory manager responsible for managing the memory, RAM. Process manager responsible for managing the process. Services are capable of communicating. Again, user. These services services are capable of communicating with the resources. Now tell me, if I take one example, I'm using this application called Paint. Will you agree this is an application? Paint is an application, Notepad is an application, MS Word is an application, MS Office, MS, whatever the things are, those are applications. Will you agree? These applications internally communicates with a file manager. These applications internally communicates with a file manager. Will you agree? This file manager is responsible for managing the hard disk. If you're getting the point, there are so many applications are there to create a file. I can create a file using the VI editor. I can create a file using the cat command. I can create a file using the Paint application. I can create a file using the Notepad. I can create a file using the WordPad. All these are different applications. If I accept this point type 1, all these are applications. Who uses the applications? Who uses the applications? User. What these applications will do inside? What these applications will do inside? Communicates with kernel, communicates with OS, main component, file manager. These applications communicates with the file managers, right? These managers are responsible for This managers are, this kernel is responsible for, this managers are responsible for communicate with the hardware. Correct. Now can you tell me, if file manager is not there, there is no use of application. If there is no file manager is there, not there, there is no use of application. Now you tell me, applications are mandatory or services are mandatory? If applications are mandatory or services are mandatory, can I say services are mandatory? If one application is not there, I can use another application. Now can you tell me, if I don't have this application to browse an internet, can I use another application? If I don't have this application to browse an internet, can I use another application? Answer is yes. But I have these applications, but internet is not there. Can I say there is no use of this application? I have plenty of applications, but internet service is not there. In network manager is not there. So there is no use of this. If I don't have the notepad, I can use one more application to create a file. If I don't have the notepad, I can use one more application to create a file. But file manager itself is not there. Logically think, but file manager itself is not there. Can I say there is no use? Let's take one example. Suppose I connected one printer to my laptop. To take a printout, I need one application. Will you agree? In this application, maybe print option will be there. In this print option will be there. Printer is there, but printer drivers are not there in my laptop. Printer manager is not there in my laptop. So can I say there is no use of this application? All of you getting the point? All of you getting the point? If I connected a new printer to my system, first I need to install the drivers. The drivers are nothing but managers there. The drivers are nothing but managers here. Is it clear? So if this application is not there, can I take any other application help to take a printout? If this application is not there, can I take the any other application help to take the printout? Yes or no? Please let me know. Yes. Now you conclude and tell me. Now you conclude and tell me, applications are mandatory or services are mandatory? Now you conclude and tell me, applications are mandatory, services are mandatory. Services. User uses the applications, applications need a services, services are capable of communicating with the hardware. All the services combinedly technically called as, a kernel. Kernel is nothing but a core of an operating system. Kernel is nothing but a core of an operating system. If any doubt in this, please let me know. Some of the services by default, when you install the OS, it will come. Some of the services you need to externally install it. Will you agree? Will you accept this point? Some of the services by default, when OS is installed, automatically it will come. But some of the services you need to install explicitly. Some of the drivers, like any external things, if you add it. User uses. Now in your smartphone, you are using applications. Internally, that applications required services. Those services are capable of communicating with the respected resource. So, operating system, majorly two components. Operating system contains the two things. One is applications and another one is the services. User uses the applications. Applications communicates with the services. Services are capable of communicating. Service means, can I say, main team of the OS kernel that is capable of communicating with that. Applications are optional. If one application is not there, I can use another application, but service is mandatory. Now, can you agree? Will you agree? Nowadays, in your smartphones, around 90% of applications need internet service. Hmm? Around 90% of applications nowadays in your smartphone, whatever you are downloading. So, will you agree? It required internet service. If one application is not there, I can use another application, but internet services itself is not there, I can't use. Very simple fundamental concept point here. And these applications and services combinedly called as these applications and services combinedly both called as OS. OS. Now, can you tell me, when you are using your smartphone, some notifications comes like these many applications updation is pending. Yes, sir? Pop-ups will come. Yes. How many of you know? How many of you observed? For your OS is also updation will come. It will not come regularly. Rarely it will come. For your OS also updation will come. Now tell me, system update. When you are updating the OS, you can't use applications, right? You need to restart the system once the updation is done. If you're getting the point. OS updation means operating system updation means, can I say all the managers in the manager, some bugs are there, those might have fixed there. Now, my request to everyone, those who are using a smartphones, you might have observed in your smartphone, Android OS is there. You need to find out which kernel version that is. Android OS is there. You need to go and settings and somewhere. You need to find out what is the kernel version of that OS which you are using there. What is the difference between the restart and shutdown? Why any update need a restart? So D3 is asking, are you talking about operating system? Are you talking about D3? Are you talking about operating system? Oh yes, okay. Restart means again it will start. It will shut down once again, automatically it will start. Shutdown means total shutdown. I don't know, in a Windows 10, if any updation comes, it will ask you update and restart, update and shutdown. Is it? All of you observe? If any update came in a Windows 10, it will ask. So what happens? Restart means whatever the old managers are there in the RAM, that will be filled with the new managers. Can I say when you switch on the system, your OS should be loaded into the RAM for execution. Without restart, what happens is the old managers will be there in the RAM itself. The updation will not be affected. So that is the reason. In the mobile phone, they will ask you, once the OS is updated, they will inform you to restart the mobile phone. Once you restart, what happens is, once you restart, all the managers, fresh manager, new managers will be there. One of the student is saying that his mobile kernel version is 4.19.152 something. Yes. You can open the document and you can read it also, license and all other things. But document they will kept normal. 4.9.117. On restart, old managers are deleted, definitely. But different kernel versions will be there. I hope all of you got a little bit an idea what is a kernel, right? Kernel is not a big word, very simple. Kernel is nothing but a core of an operating system. All the managers are combinedly called as a kernel. So in this Linux system programming, what we are going to do is we are going to communicate with these managers, some of the managers. In these modules, we are going to communicate with the kernel using the functions called system calls. Okay. In this, what we are going to do is we are going to communicate with a kernel. We are going to communicate with the operating system managers, file manager, process manager, memory manager, thread manager, signal manager, resource manager, like this. All the managers we are going to communicate via program, through program. Or if you're getting the point, through program, we are going to communicate it. That's what called as a system programming. Is it clear? Anyway, today is a Saturday. I'm going to wind up the today's session. Strength is also less. So I'm going to wind up. I hope up to this you got the points, right? Up to this you got the points. Yes? Type yes in the chat box. Okay. In the next session, Monday session, we'll talk about these two. And we need to discuss the booting steps also. When you switch on the system, till the login screen comes, what is the background work happened? In a simple and simplest way, we need to discuss it. Is it getting? Yes, I'll share this PDF, don't worry. One student is asking, sir, printer previously we need install the external devices. In this case, see, nowadays the smart printer, smart embedded devices are coming. When you plug in it, it will automatically search the driver is there or not. If not there, it will ask you automatically. Previous days, what happens is they will provide you one different CD. You need to install the CD. You need to put the CD. Nowadays, laptops are not coming with a CD drive also, right? Nowadays, laptops are not coming with a CD drive also. So, whenever the technology increases, whenever the things are happening, enhancements are happening, becoming a very smarter. When you connect a new device, automatically it will search the driver is there or not. If not there, automatically